So let's compare the perceptron algorithm and the gradient descent algorithm. In the gradient descent algorithm, we take the weights and change them from wi to wi plus alpha times y hat minus y times xi. In the perceptron algorithm, not every point changes the weights, only the misclassified ones. Here, if x is misclassified, we'll change the weights by adding xi to wi if the point label is positive and subtracting if it's negative. Now the question is, are these two things the same? Well, let's remember that in the perceptron algorithm, the labels are 1 and 0, and the predictions y hat are also 1 and 0. So if the point is correctly classified, then y minus y hat is 0 because y is equal to y hat. Now if the point is labeled blue, then y equals 1, and if it's misclassified, then the prediction must be y hat equals 0. So y hat minus y is minus 1. Similarly, if the point is labeled red, then y equals 0 and y hat equals 1, so y hat minus y equals 1. This may not be super clear right away, but if you stare at the screen for long enough, you realize that the right and the left are exactly the same thing. The only difference is that in the left, y hat can take any number between 0 and 1, whereas in the right, y hat can take only the values 0 or 1. It's pretty fascinating, isn't it? But let's study gradient descent even more carefully. Both in the perceptron algorithm and in the gradient descent algorithm, a point that is misclassified tells the line to come closer because eventually wants the line to surpass it, so it can be in the correct side. Now what happens if the point is correctly classified? Well, the perceptron algorithm says do absolutely nothing. In the gradient descent algorithm, you are changing the weights, but what is it doing? Well, if we look carefully, what the point is telling the line is to go farther away. And this makes sense, right? Because if you're correctly classified, say if you're a blue point in the blue region, you'd like to be even more into the blue region, so your prediction is even closer to 1, and your error is even smaller. Similarly for a red point in the red region. So it makes sense that the point tells the line to go farther away. And that's precisely what the gradient descent algorithm does. The misclassified points ask the line to come closer, and the correctly classified points ask the line to go farther away. The line listens to all the points and takes steps in such a way that it eventually arrives to a pretty good solution.